In this video, I'm covering section 7.1/7.2, the law of signs / the ambiguous case. And the law of signs says for any triangle ABC. So before now, the only trig that we had for triangles was right triangle trigonometry. SOHCAHTOA only works if you are a right triangle. This is for any triangle ABC. Then sine of big A over little a equals sine of big B over little b equals sine of big C over little c. Or these can also be written the other way. So little a over big sine A equal to little b over big sine B equal to little c over sine of big C. Oops, I need to erase that. He's a little too ugly. Okay, now usually we know this line. Again, it is interchangeable with the thing below it, but this is what people usually memorize. You'll randomly just need to know the law of sines, and in 7.3 we're going to get the law of cosines in calculus. Now, chapter 6 in general is usually pretty hard for students. Almost no matter how I teach it, the results in that chapter are eh. And then we get to chapter 7 and the stars align, the world is back to normal, and chapter 7 is like easy. Law of signs, everybody loves it. So, for example, find the missing parts of triangle ABC. Find the missing parts of triangle ABC. And example number 1 is given that big A is 56 degrees 22 minutes. Big B is 48 degrees 57 minutes. And little a is 7.24 meters. Okay, so you don't have to draw a triangle in order to do the problem. I prefer to draw it, and we're going to kind of refer back to a couple things in a little bit. Okay, so big A, big B, big C. It doesn't matter where you label those, but it does mean that you've automatically labeled little a, little b, and little c. And because the little side is always opposite to the angle. And what we know right now, big A is 56 degrees, 22 minutes. Big B is 48 degrees, 57 minutes. And we know little a to be 7.24 meters. Okay, so finding all the missing parts. That means that we're looking for little b, little c, and big C. Who's the easiest to find first? In my opinion, it's big C, because big C is 180 degrees minus A minus B, which I don't even need to see this calculation on your paper. You can just do it all in your calculator. Make sure that you're in degree mode. And we're going to do 180 minus 56 degrees, 22 minutes, minus 48 degrees, 57 minutes, and that is equal to 74 degrees, 41 minutes. Now, on the test, I will be very specific of where I want you to round to if you need to round. We don't need to round our degrees, minutes, seconds, because we can work exactly. I will be looking for exact as well as approximate when it's appropriate, slash don't round the angle if he's in degrees and minutes. Okay, so we have big A, big B, big C now. We're looking for little b and little c. It does not matter who we find first. I guess I'll start with little b. So I know that sine of big B over little b is going to equal sine of somebody over his side. And we can't use angle C and side C because we have to know 3 out of the 4 things in order to find the 4th, which is why we need to use big A and little a. So that is going to equal sine of big A over little a. Again, filling in what we know at this point, we know that sine of 48 degrees, 57 minutes over, we don't know yet, little b is equal to sine of our 56 degrees, 22 minutes over the 7.24. We're going to cross multiply. So 7.24 sine of 48 degrees, 57 minutes is equal to b times sine of 56 degrees, 22 minutes. Divide both sides by sine of 56 degrees, 22 minutes to get our exact answer for b, which is 7.24 sine of 48 degrees, 57 minutes, divided by sine of 56 degrees, 22 minutes. And then we can put that in our calculator to get our decimal approximation. Our b is approximately. Now, because the side length that you were given, this A equal to 7.24 meters above, I gave you the side length to 2 decimal places. Whatever you're given to is just where you should round to. On the test, I will give you specific directions of where to round to, but your guide for like the homework is just round to wherever you're given. Okay, so 7.24 sine of 48 degrees, 57 minutes, divided by our sine of 56 degrees, 22 minutes. And I hit equals, and b is approximately 6 point, oops, I hate it when I do that, 6.56 meters. Don't forget your units. Okay, so next we need to find little c, because now we have little b. And in order to find little c, we are definitely going to be using sine of big C over little c, but I can either set him equal to sine of big B over little b or sine of big A over little a. Why are we going to pick sine of big A over little a? Because they are not rounded. There will be occasion in this chapter when you can't avoid the rounded answers, and I know that, and I'm fine with it. But when you can, you need to. So, plugging in what we know from above, we know that sine of 74 degrees, 41 minutes over our little c is equal to sine of 56 degrees, 22 minutes, divided by 7.24, cross multiply to get 7.24, 7.24 sine of 74 degrees, 41 minutes is equal to c times sine of 56 degrees, 22 minutes. Divide our 56 degrees, 22 minutes to the other side to get our little c is exactly equal to 7.24 sine of 74 degrees, 41 minutes, all over sine of 56 degrees, 22 minutes. Then we can put that guy in our calculator. So 7.24 times sine of 74 degrees, 41 minutes, divided by sine of 56 degrees, 22 minutes. According to my calculator, my c is approximately 8.39 meters. C is approximately 8.39 meters. Okay, so again, we are also going to get a law of cosines in the next section. And there are going to be certain times when you're going to have to either use the law of sines or the law of cosines. And so when you are given an angle and the side opposite that angle, that is going to mean that you're going to use the law of sines. Now, when you're given two angles, you find the third angle, then find the two missing sides, you're good to go. I am going to pause my video and do another example.